Okay, so we just got done talking about the pressure time scalar, okay, which would look something like this, in which pressure is on this axis and time is on this axis, which starts at 0 and increases this way, and the pressure increases this way. And we said that we're in volume ventilation, in which the tidal volume is 500 milliliters, and we're blowing that volume in at 60 liters per minute. Okay, obviously they're not the only ventilator settings, but as far as to describe this, they're the only ones that I need. My PEEP level starts off at 5 centimeters of pressure, and then as this 500 milliliters is blown into the patient's lungs at 60 liters a minute, the pressure goes up. Okay? Once that 500 milliliters of gas is delivered, the pressure would simply come back down, and then it'd go back down to my baseline PEEP level, which is still at 5. Okay? From this model so far, all that we would know is that the PEEP level is 5, and my peak inspiratory pressure in this example would be 55 centimeters of pressure. Okay? Which some people would say that is high. So since this is high, you have to ask yourself, well, why is it high? And the first thing to do in volume ventilation is to do an inspiratory pause. And when you do the inspiratory pause, you would find that you separate this pressure scalar into 2 different levels. Okay? In which it would look something like that. And we just described that this level, the plateau pressure, down to your baseline pressure, would be the pressure used to overcome static compliance. Okay? It is not static compliance, it is the pressure used to overcome it. And then this level from here to here is going to be the pressure used to overcome airway resistance. It is not airway resistance, it is the pressure used to overcome it. So then the next thing that people start to ask is, well, why do we separate these 2 things out? Oh, and one more point just to bring it back to the previous slides. This obviously is the pressure used to overcome dynamic compliance. Okay, so obviously dynamic compliance is the sum of airway resistance and static compliance. So if we take a look at these 2 different levels and we start to explain why those pressures change, we get a better understanding on how to manage our patients. So airway resistance is caused by numerous factors described by Reynolds' law. The 2 big ones that we want to look at with mechanical ventilation is 1, the endotracheal tube size, so ET tube size, okay, and 2, the flow going through that endotracheal tube, shown here by a V with a dot above it, the symbol for flow. So if I were to do 2 different things to each one of these, I will change airway resistance. If I increase the size of the endotracheal tube, make the size bigger, I will not cause as much pressure going through it because you will not have as much turbulence going through a big hole compared to a small hole. If I slow the flow rate down, I will not have as much turbulence because as flow rate decelerates, it becomes more streamlined. On the other side, if I make my endotracheal tube and I take it from a size 8 down to a size 7, or if I take my flow rate and I go from 60 liters a minute to 120 liters a minute, either one of these will cause this change. You will now have a higher peak inspiratory pressure, but look what happens to the plateau pressure. It stays the same. Well, why would that be? Well, changing the size of the endotracheal tube or changing the flow rate didn't change your static compliance. It had to do with how much airway resistance was going on. Just like if I were to do this, and bear with me for 1 second, if this is my before, and then I were to come back an hour later, and I were to see this, you would be able to look at that and say, my airway resistance is unchanged. My static compliance, however, has gotten better because the plateau pressure has dropped. Okay? Or I've changed my tidal volume from 500 in the brown to maybe 250, represented by the green. However, the airway resistance is the exact same difference. And that's how you're going to diagnose the difference between an airway resistance problem and a static compliance problem.